All right, everyone. As previously mentioned, today we're going to be talking about relational database management systems. Throughout this course, we're going to be concentrating in PostgresQL as our main database management system. You'll be learning how to connect it with Django, just like you learn how to connect it with Flask. And we'll also be utilizing this database later on when we go into creating our learning models for storing weights and biases so that we're not grabbing things from scratch or training our model from scratch every time it gets invoked. So we talked a little bit about databases before. Today, we're going to kick off the lecture by talking about what is a schema design, how to create a schema design. We'll talk about good and bad practices. From there, we'll move into understanding some entity fields, and then we'll go into some actual practical application of drawing out specific scenarios for database management systems utilizing SQL Draw. Just in case you don't remember this link, I'm just going to go ahead and grab it here, share with everybody here on the Zoom chat so that everybody has it available to them. And if you would like to check it out and make your own account, you can. And from there, we'll go into the second portion where we'll actually start writing some SQL data inside of a SQL file. At this point, does anyone have any questions over what we'll be covering today? Okay, so I'm gonna start off our lecture with a little disclaimer. SQL is not going to be the hardest part of our entire cohort here. It is a very straightforward language. But with that said, it is very easy for people to say, "Oh, SQL, no worries, I got that," and they just kind of put it on the side. A couple months go by, you get an interview, and then they tell you, "Hey, write me a join query that selects this and this field from this table." And all of a sudden you're like, "Oh, hey, I haven't written a single line of SQL in about 2 or 3 months. I have no idea how to do this." So don't let it sneak up on you. Make sure that you're continuing to practice your SQL queries and your practices as far as how to create a database schema throughout the entire cohort. Note that Django will do most of this work for you, so it's going to become a little bit harder to ensure that you're practicing this. But at the very minimum, ensure that you always draw out a database schema before you start creating any sort of models within Django. All right. So what is schema design? Can somebody read this paragraph here for me? Oof, no readers, huh?
I can read it.
Awesome. Thank you, Dustin.
What is schema design? Database schema design refers to the process of defining the structure that represents the organization of data in a database. A well-designed database schema is crucial for ensuring data integrity, performance, and ease of maintenance. Here are some good practices and potential pitfalls to consider when using or when starting your database schema design.
All right.
Oh,
Oh, that's great. Thank you. I appreciate it. All right. So schema design, it's important. It allows us to draw out data and think about the different problems that we could come across whenever we're managing data, right? One of the biggest problems that we'll always come across is relationships. How does one specific record relate to another? And how will we manage these relationships? Right? We'll talk about relationships more in detail later on. But try to put that away in your back pocket so that when we get there, the light switch comes on, that's going to be a really important part to pay attention to. All right, so normalization. There's first, second, and third rules of normalization. I don't want to go too far in detail into this because it's going to be a little bit above our heads, but it's definitely something you all should look into. What does normalizing your data look like? What are the first, second, and third rules of normalization, and how could you implement them? The utilization of primary keys. So primary keys, we've seen it before, and we've actually been practicing this from the very start of the program. If we remember when we were writing the cell phone application or when we were writing our assessment one code for object-oriented programming, you're essentially creating a database where the ID of each individual user was stored as the key, and the corresponding information, which would be the record, was being stored as the value within that dictionary. Well, now instead of doing it in Python and having to do all of these different validators as far as how types should be interpreted, maybe some sort of restrictions as to what should be allowed as proper or improper input for each individual field or entity within the program. Well, now we're utilizing a database that's going to be doing this for us. But the primary key concept is going to stay the same, right? I want a quick and easy way to be able to access one set of data. And the best way to do that is utilizing a primary key. All right. So normalization and using primary keys. Does anyone have any questions about that? Okay, moving on. So foreign keys for relationships. Whenever you're making a connection to any sort of other record, you want to make sure that you don't implicitly make these connections, right? So you don't want to just say, oh, well, this is going to be an integer type that that we're going to utilize as a reference for a primary key. You want to actually ensure that you place within the code, hey, this is a constraint. This is something that I want you as the database to ensure is happening. I want you to ensure that every time there is a new primary key that shows up here, or an integer shows up here, it corresponds to an existing record inside of another table. All right, because if we don't have that constraint in there and we're just storing numbers, well, when I delete a record, my database doesn't know how to necessarily manage those relationships, right? So a good example of this is, think of a one-to-one relationship being you, a passenger going to an airport, and your passport, right? So your passport's a completely different record. You, the passenger, are one individual record. Well, there's a one-to-one relationship. Every passenger should have one passport, right? Well, how should it handle this information, or how should my database handle this information? Well, if one of my passengers were to no longer be boarding on a flight today, and I remove them from my database, I see them coming in, well, any information that I have responding to their passport should be dropped from the database as well, right? It should disappear. I don't need that information. Why do I need to know about their passport if this passenger isn't here? Well, unless I specifically tell the database, this is a relationship, here is the constraint, and this is how you should handle that relationship, it's not going to drop that passport. And we could end up with a massive amount of data that isn't properly connected to another table. Does anyone have any questions in regards to foreign key relationships? Okay, great. Moving forward, we have data types and constraints. So when it comes to data types, we've already seen it, especially with JavaScript. It is extremely important that we're choosing the correct data type, right? When you're working with JavaScript, there's such a thing as a shallow comparison and then an in-depth comparison. There's pass by reference, pass by value. There's all kinds of different concepts as to how you could reference one specific value that's being stored in the database. But more importantly, right, whenever I have some sort of decimal number, well, I need to make sure that I know what sort of level of accuracy is it that I want my database to have for this decimal. Let's say I'm working within a store, right? If I'm working within a store, it's extremely important that I know how to manage or record the numerical values for each individual item that's in stock, right? If I were to mess up something within the database schema, and let's say that I want the store values to be analyzed as a string versus a decimal point, well, when I go to do any sort of mathematical operation that should have been extremely easy, well, now it's going to turn into a huge complicated problem because I'm doing typecasting. I'm trying to ensure that everything is the correct format, that they're the matching types before I'm actually able to do any sort of addition or subtraction or any other sort of mathematical application, right? So ensure that you're paying attention to types, especially when it comes to your database. You'll realize soon, once you start working with larger applications, that creating your database schema, or the part where you're thinking about all the problems and the actual creation of it, is so vital, because once you've created it, if you start storing data in it and let's say you try to develop a new feature but you made something that was coupled within another record, and you actually find out that you needed to be individual, so that you could mess with it with a new feature, well, now you're going to have to figure out a way to grab all of the data out of your database, utilize Python to break that data up, create a new database schema. You're going to have to drop the original database, create the new one, and then load all the old data back into the new database. Right. So it's a lot of steps, a lot of processes, and it's not something that you necessarily want to do, if ever, is actually to drop your database. So the more you think and do some forward thinking about, oh, this is going to be a problem that I identify, the less headache that you'll have later on in the development process. All right. Does anyone have any questions about data types and constraints? Okay, great. I know I'm doing a lot of talking. I apologize to everyone. Unfortunately, the first lecture is definitely more of a talking part, but we'll get into some code and examples here shortly. All right, the next thing that we have is indexes. We haven't heard this term before. Well, indexes is something that you can create within your database schema for specific records. Let's say that I'm grabbing students, right? And I've noticed that I'm always grabbing students by their student ID. Well, performance-wise, as my database grows, depending on how many students I have, it's going to become harder and harder for PostgreSQL to conduct that SQL query to find the correct student ID and bring back that student, right? Well, how do we compensate for that? Because we know that the whole reason why I'm utilizing a database is to be more efficient in the way that I'm grabbing data or creating data into my database. That's where indexes come into play. I can specifically tell PostgreSQL, hey, I want you to allocate some extra performance space for any query that touches this one specific field. I want you to place an index on it. And by doing that, well, as my database grows, yes, it's still going to become harder for PostgreSQL to grab that data, but the performance speed at which it grabs that data will be significantly different and compared to a database that didn't have this index. So indexes are super important. They're just to speed up the performance of the database whenever you're grabbing information. All right. And then consistent naming convention. When it comes to PostgreSQL, don't use capital letters. Try to avoid numbers at all costs. And I wouldn't include spaces in between your database naming conventions or data tables. Utilize underscores, snake casing, try to make it all together. Now, I say this ahead of time because it's happened before where somebody capitalizes a data table within PostgreSQL, and then Postgres has really hard time identifying a capital letter within SQL queries. So please avoid capital letters at all costs. All right, and then documentation. Well, just like everything we've learned here at Code Platoon, you can write code and write code as much as you want, but I'm sure we've all come to this experience already, where if you go back and look at code that you wrote a week prior to, or 2 weeks prior from where we are now, it's almost like you didn't write it to begin with, right? Like it's happened to me. Sometimes I go look at a project that I wrote maybe a month ago, and I'm reading a function and it just comes up to my head like, what is this doing? What is this pile of trash that I've just created? And why is it here? Right. And unfortunately, because I don't follow my own advice, sometimes I don't have the proper documentation to explain the purpose of this function. Right. So my knee-jerk reaction is, all right, well, I obviously don't need this function. I don't think it's getting called anywhere. And I go highlight it all, press that backspace key, and then all of a sudden my server is like, hey, we don't know how to work anymore because this function's gone. All right. Hopefully we don't run into this experience very often, but please note documentation is extremely important. When you start working in massive projects, you're not going to be working on a project that's starting from scratch, which is what you're used to as of now. You're used to grabbing a project, starting from scratch, changing things. You're going to be working with other developers, other people's codes. You could be picking up a feature that was developed maybe 2 or 3 years ago. Maybe it's already outdated as far as which version of the language it is that it's using. So you pick up this feature and you're trying to work on it. Well, if the developer before didn't leave behind any comments, if they didn't leave behind any sort of markdown files that explain why this feature is here or why this function exists where it does and where it gets utilized, well, it's just going to be that much harder for you to pick up that project and carry it forward, right? It's not going to be common. It's not going to be an uncommon experience to pick up someone else's code and get tasked with completing their that project or extending that project. So we need to start thinking about it from that perspective, right? When I write code, it's not just for me, it's for the team. All right. So that's going to cover all of the good practices. There's definitely more, but these are the ones that we're going to highlight. Does anyone have any questions in regards to any of the good practices that we covered today? Go ahead, Eric.
Are we going to see an example of using an index?
Yes, we will. We're going to be covering indexes. I believe that will go tomorrow.
Okay, cool. Thanks.
Of course. Momo?
Yeah, I just want to know the indexing is like for time consuming, because what I understood, the ID, the unique key, okay, is the unique or the key is this. This is unique for each uh, element or whatever inside the table. So what would be the difference if the index is like for the whole table or for the whole thing, not for the element?
Yeah, that's a good question. So when it comes to, it might be easier to demonstrate. Let me go ahead and pull up TL draw here. And let me pull up a different thing here. There you go. So what we're talking about here is we have a table, right? This table may have a couple of rows. Let's say it just has 3 for simplicity's sake. All right, so there's my 3 rows, and maybe over here I have ID, over here I have name, and over here I have age, right? Well, when I add an index, my index isn't going to be applied to the entire record itself, or the entire set of a record. It's going to be applied to one specific field of the record. So let's say I find myself always asking, hey, I want to grab all of the students that are above this age or below this age, or I want to grab all the students that are this specific age because we have this program that's super good for them and they should sign up for them, right? Well, if I find myself consistently writing something that says, hey, depending on the student's age, this is what should happen, then I should have an index pointing to that age. And this is going to allow PostgreSQL to say, oh, well, if you want an index there, then what I need to do is I need to ensure I allocate some performance space for the field age. All right. So then as my records continue growing here, or as I continue growing more students, it's still going to take a little bit more time to grab that, but it's going to be faster than if I didn't have the index. Does that answer your question, Mama?
Yeah, that means the index is just conditional, right? For group of data. Group of data has like relation between them, right? That's what you meant. Like the student has age over 21 years old. So all of those students will be have the same index, right? Under one index. That's what you mean?
No. So the index is aiming at age specifically, the field. It doesn't matter what the query is. What matters is that that field of age knows that it's going to be queried often. So because it knows that it's going to be queried often, we're giving PostgreSQL extra performance space to execute those where clauses.
Okay, yeah, I got it.
Okay.
Okay, thank you.
Of course. All right. Any other questions? Okay, great. if we go into bad practices, we're going to see a denormalization again. Look into normalization. Essentially, what normalization stands for is you don't want to put too much data inside of one record. It's kind of like the OOP concept of the single responsibility principle, right? Where if I want to track a student and their student information, well, I wouldn't track like the student address. I wouldn't track a student's birth date, or I wouldn't track a student's academic record within my student class, right? My student class would likely be first name, last name, and then some sort of ID. And then from there, I would have an address class, and that address class would be connected to the student, right? So the student would have in composition an address, and then a student would have in composition some sort of other record that carries the rest of the details for the student, right? So just think about OOP following the single responsibility principle whenever you're creating these tables. Ignoring indexes. So indexes are important. Data is going to grow. It's only going to get bigger as your application gets bigger. So you want to make sure that you have a way to compensate for performance. Unrestricted null values. We're going to be talking about null pretty extensively later on in the cohort. There's a whole table that was provided for us in 2 scoops of Django that talks about, hey, this is what should and should not be null. And these are some scenarios in which it should be. And if we don't talk about it during the PostgreSQL portion, I know it's inside of the Django portion. So we'll be covering null values, when it's acceptable and when it is not acceptable shortly. Ignoring relationships. So we spoke about this a little bit. If you don't have a relationship that's being enforced by PostgreSQL, you're just accumulating data that doesn't necessarily have some sort of cascading effect, right? If I remove one record, well, all the records that are attached to it, which one should be removed and which one shouldn't? Well, that's what relationships allows us to do. Inconsistent naming, just like in programming, you know, having inconsistent naming conventions could definitely throw a loop in your code. Lack of documentation. This stops other developers from being able to work with you or work within your database. So you want to make sure that you have good documentation. And then ignoring security. We'll talk about security, especially when it comes to deployment and how to handle that later on when we talk about our Docker lectures and we start moving into how to handle environmental variables within deployment. And then this part here, ignoring scalability. Essentially, like I said earlier, your data will scale. Everything that you're making in your application, when you create an application, you're hoping users will use it. The more users you have, the more records you'll be saving. You also have to keep in mind that you probably aren't going to keep the same project exactly the same the entire time you work through it, right? You want to start with a minimal valuable product, and then from there you develop each individual feature. Well, developing new features could require more tables. So you need to make sure that your database is able to handle having more tables being created without crashing the original database schema that you've already created before. All right. Does anyone have any questions over some bad practices? All right, no questions. So let's start talking a little bit about some fields here and how they work. So here I'm in Drawsql. Let's start talking about some fields, right? So when I create a table, you'll see, we'll just call this our example table. My example table already comes with an ID here, and it's telling me that it has a big integer, and I'm pretty sure this is specified here below. Doesn't look like it is. All right. Well, big integer, what this means is that it can go, there's a difference between big integer and integer, and you'll even see that you have small integer. The only difference between these three is memory space and how high can they go, right? So if I have something like integer, I don't know off the top of my head, but let's say it only goes up to about 500, right? Well, if I'm creating a database that could have a possible crazy amount of records, well, I would want a big integer because I want to make sure that PostgreSQL could handle something that goes past the thousands as far as records being stored inside of this table. All right. So far I have my table. It has my ID for big integers, and that's my serial primary key fields, right? So it goes into what it's used to. We're going to be utilizing this a lot for referencing and for creating some connections between records. Now, let's say we have some var and text fields. Well, let's talk about that. All right, so let's say I have a name, and let's talk about the different things that we have here. So we have a varchar. We also have a char, which you'll notice both of them have a limit of 255 characters, right? And then we also have a text. Okay, so the easiest thing to analyze is the difference between text and the other two. Well, text allows for something like a biography, right? If I'm storing a biography for each individual user, like for example, that portion in Facebook where it says like, tell me about yourself, or maybe LinkedIn where it says, tell me about yourself, right? That's getting stored inside of a text. If you go into something that has some sort of character limitation and says, hey, we can't allow for you to use more than 250 characters here. Their database likely is using something like a varchar to keep track of how much space is being allocated for each user. So text occupies a good amount of memory space because it doesn't have a limit as to how many characters it's going to be storing. Right? Now, char, this one works a little bit differently because I could specify, hey, we're only utilizing 10 characters. And that's great because it's not occupying a crazy amount of space like text would. But the problem with char is that even if I only use 2 or 3 of those 10 spaces, it still occupies the memory space for all 10 spaces. Not necessarily what I want, right? I want something a little bit more flexible. So what we're going to typically use is varchar. And with varchar, I can say, hey, I want you to allow for 20, right? Like maximum, you're going to have 20 characters being placed into you. And it's been created, it says, all right, well, we'll allow for a maximum of 20 characters. But if I only utilize 10 of those 20 characters, well, the other 10 bytes or whatever it's being interpreted to, rather than still being occupied, it's being released back as memory that can still be utilized by the remaining of the program, right? So that's the difference between those three. Does anyone have any questions regarding varchar, char, and text? Momo, go for it.
So why we don't always use varchar as long as the varchar and char the same, but varchar is causing more optimization for our space and why we use this? Why we use the char? Is there specific need for the char?
Yeah,
Because I feel the varchar and char is the same, but varchar is more giving us more better code or better, right?
right. It's giving us more power. And yeah, definitely. So when it comes to specific uses of character, let's try to think about something. And I'm trying to come up with a good example that would relate back to it. Without getting into too many hypotheticals, char came first. It was the easiest way for us to store characters without utilizing text fields. Somebody said, hey, like, yes, this is efficient, but I would rather utilize a little bit more of memory space when it comes to creation and performance rather than for storing values. So they came up with varchar, and that's what came after char, right? So char is just something that's been outdated. You could find specific use cases for them. I can't think of one off the top of my head, and I don't want to try to create an example that might confuse other people. Does that answer your question, Momo?
Yes, sir. Thank you.
Of course. All right. So there you go. We covered all of our different texts or different ways of storing text, right? Now let's go into a numeric and decimal fields here. So let's say here I have something like age. We've already talked about our integers fields, right? But maybe I have something like current, I don't know, finances, right? Well, in this case, I would want to handle something like decimal. And decimal takes in two arguments. The first argument, and excuse me, everyone, let me try to zoom in. I hope that's a little better. The first argument is the total number of integers that it will be storing. And the second number is where I would want the integers to stop, or excuse me, the decimal to start. So for example, if I have something like $125 with 23 cents, it would be a decimal of 5 total integers, because here we can see that I have 1, 2, 3, 4, and 5. All right. And I have a decimal point at index 2. So that's what turns it into 125 decimal point 23. All right. Now the limitation that comes here is that I could only go all the way up to 999.99. If I wanted to go anything above that, well, then I would need to allow for another index of 6. And then I could go up above. All right. Does anyone have any questions regarding decimals or integers? Go ahead, Tim.
When you put the decimal at the 2, why didn't it go to the first 2? And
That's-
you had 1, 2, 5, 2, 3 written as the first example.
Yes. The 2 is in reference of indexes from right to left. So 1, 2. And then
Got it.
presses the
Thank you.
decimal. Of course. All right. Any other questions? Okay, great. The next one we have is date and timestamp. So here we go with, let's say, date of birth. And then let's also add a time of birth. All right. So now what's the difference between these? Well, a date field stores quite literally just that, only the date, right? So today is 2024-07-08. All right. Well, what does a timestamp store? Well, a timestamp stores 2024-07-08. And actually, this is not TZ, so it doesn't store my time zone. So it says 2024-07-08. Then it says total hours is 7, total minutes is 36, and total seconds is whatever seconds we're currently at. And it goes all the way up to, excuse me, milliseconds. All right, so the majority of the time, whenever you want to store some sort of date, the most typical way that this comes in handy is when a user signs up for your application. You want to set a, like, hey, this is the date that the user signed up. That usually gets stored in a timestamp basis. And if you want to get really fancy or your application needs this, you could also use timestamp Z. And what timestamp Z does is it includes the time zone rather than just the timestamp. All right. Any questions regarding date and timestamp fields? Go for it, Momo.
Yes, sir. Can you repeat the timestamp one more time? I didn't get it. I didn't understand.
Yeah. So let's see. Date field will only store something that goes along the lines of 2024-07-08, whereas the timestamp field will store it is 2024-07-08, where the current time is 07 hours with 08 minutes, and let's just say 55 seconds with 33 milliseconds. And that's the difference between the two. The top one stores only the date, whereas timestamp not only stores the date, but also stores the hour, minute, seconds, and milliseconds of the creation of the record. Does that make sense, Mo?
Yeah, that makes sense.
Of course. Go ahead, Arjan.
So I have a question on the decimal part.
Yeah.
So I see that the 6 is like how many numbers inputted in there, and the 2 is like the decimal.
Mhm.
Can you have less than let's say you only have 2 numbers, let's say you only have 23, it will still take it?
So if you only input 23, what it will interpret that as is as 0.23, right? So if you
follow the 6 numbers then?
right, so you don't have to follow the 6 numbers, but you could just do 0.23.00, and then that would get interpreted into 23.
Okay. Thank you.
Of course. All right. And then our favorite one, which I think is one of our last fields that we'll be talking about here, is going to be our Boolean field, right? So let's just say good person, and then this would just be a Boolean field, which, as we know, is just interpreted as a true or false, 0 or 1. Right? It doesn't have any sort of tricky situation within PostgreSQL. All right. Any questions up to this point? Go ahead, Erica.
Just for the timestamp Z, how does that record the timestamp? Sorry, the time zone.
Yeah, so timestamp Z, and please don't take my word for it because I am going off memory here, so there's a good chance that I may be a little bit wrong as to how it's doing this. But it records the same thing. What you'll see at the end is you'll see something like time zone PST. So timestamp TZ will also include the time zone being set from the point of origin where the record was being created. Does it answer your question, Erica?
Yep.
All right, Momo?
Yeah, sorry, one more time. What did you mean by the operation, the time of the operation? Because this is not showing what time, right? It's showing like the time, like time span. Like, so what did you mean by the time of the operation?
Oh, got it. By the time of the operation. So what I mean is, like I said, we're talking about the most typical place where you'll see this being created is, hey, a user just signed up for this is a brand new user, he just signed up for my application, right? Well, I want to see what date he signed up. So if you want to utilize something like timestamp, the same time that that user gets created, you would just do the default time as now. So as soon as that operation is happening, that object or that record is being created and stored into the database, it's going to pull the timestamp from your local machine or the virtual machine that's running this API and store that inside of the database.
Okay, so okay, I got it. Thank you.
Of course. All right. So there you go. There's a couple of fields. It doesn't seem like there are any other questions regarding some fields. So let's start talking about some relationships. Let's see. So we have our many-to-many relationships. We have our one-to-one relationships. And then we have our one-to-many relationships. So let's talk about this in a more productive way. All right, so I'm going to go ahead and go with circles here. And I'm going to try to make a couple of examples here. So we've talked about a one-to-one relationship already, where a person has a passport, right? They would be connected as a one-to-one relationship, meaning that only one person can have a connection to only one passport. So if I were trying to do something like create a separate passport, and then I try to attach it to this person, well, that would throw an error. It would say, hey, this person already has a passport and this is only a one-to-one connection. This passport cannot be managed or it can't be connected. If you want to connect it, then you need to erase the original connection in order for us to connect. All right, so there's our one-to-one connection. Does anyone have any questions regarding a one-to-one relationship? All right, no questions there. Let's try to do an example of a many-to-one. All right, so let's say these are all suitcases. We're sticking with our passport here. So here is one person. And this is all luggage. When you check in your bags at the airport, you'll notice that even if you're flying with another person, typically each bag is connected to one user or one passenger, right? So I'm going to go ahead and say, oh, well, I have a many-to-one connection. Oh, hello. Let me try to fix that there. Right, so many luggages can belong to one person, right? If I try to say, hey, well, there's this other person that's trying to claim this luggage from the baggage claim, and they're saying that they're the owners, and they try to connect to it, well, this is going to throw an error. It's going to say, hey, these luggages already have a person that they relate to. You can't have a different person try to grab this luggage because it doesn't belong to them. All right, so there is my many-to-one connection. Does anyone have any questions in regards to a many-to-one relationship or a one-to-one relationship? Okay, doesn't look like there are any questions. So let's go ahead and move on into our last type of relationship, and probably the most confusing type. This is going to be our many-to-many. I should have just written person first. There you go. So let's say person. So there's our three people. And these people, when they're flying, they don't necessarily have to take one plane, right? They could be flying out of separate airports. Maybe some of them have a connecting flight and some of them don't. Well, this is where the many-to-many connection would come in, right? And let me fix that here. Where you can see it turns into kind of a spider web. All right, so this one person here is taking flight 1. They are then taking another flight named flight 2. And then there's flight 3, which you'll notice that flight 3 is only being boarded by one person, right? All of my flights still have the capability to be a many-to-many relationship. It doesn't have to have multiples. But we can see how it gets gibberished up here, right? Where, oh, hello. We may have multiple instances or multiple people loading into multiple flights and multiple flights loading multiple people. Right, so there's our many-to-many relationship. It looks more like a spider web. All right. So we've seen a many-to-many relationship. We've seen a one-to-one relationship and a many-to-one relationship. Does anyone have any questions regarding relationships? Go for it, Chris.
So for a many to many relationship, is this like saying I can search one flight either 1 or 2 or 3 and find that person? And vice versa, if I search the person, I can find the flights they're gonna take.
That's correct. Yes.
So for a many to one relationship, for the luggage to the airport, we can't search for the luggage, but we can search for the person that owns those luggage.
Yes, the connection would be at the luggage level. That's correct. Because if the person is removed, the luggage would get dropped. Right.
Okay. Thank you.
Of course. All right. Awesome. So there's our 3 connections. I'll make sure that whatever I'm drawing gets into demos and notes. I'll download it as an image. That way it doesn't get lost. So now we've seen our connections as far as what they look like in data. But what are they going to look like when they're being drawn out, right? Or if I draw it out as a database schema. Well, let's try it out. Let's say I have my passenger. My passenger should also have luggage. Oh, hello. And as we discussed, there would also be flights, right? So there you go. We have my luggage, my passenger, and my flights. Well, my luggage would belong to a passenger. All right. And I know this is going to be a many-to-one relationship. So what I would do is I would connect these two, saying, hey, my passenger or my luggage has a connection to the passenger. And this is going to be a many-to-one relationship, meaning many luggages can be applied to one passenger. And you'll see on the relationship here, we have the many on the lower side and the to-one at the passenger level. All right, so there's my many-to-one relationship. And I apologize, everyone. I forgot to add the passport as well. All right, well, my passport would also have a passenger field that it would connect to, but this one would simply be a one-to-one field. Right, so there you go. I have my one-to-one relationship and my many-to-one relationship. Before I get into my many-to-many relationship, does anyone have any questions about this? All right, so let's start talking about, oh, go ahead, Chris.
So luggage to passenger to passport, that's a many to one relationship you were saying?
Luggage to passenger has a many-to-one relationship, yes.
Okay. Gotcha. All right. Yes, I'm good. Thank you.
All right. Okay, so now with many-to-many relationships, that's where we kind of get into a tricky part, all right? So my passenger should have a way that I could see all of my flights, and just like a flight should also have a way to see all of my passengers. Well, that's an issue, right? Because I can't just have a connection between that goes like this, of passengers to flights, right? And then make them many to many. It doesn't even give me the option here, right? Because it says, hey, we can't handle this, right? So that's not an effective way of doing it. Right? So how else could I manage this connection? Well, in Django, you're going to see this happening under the hood. But in PostgresQL, because we're not utilizing a framework yet, we would actually have to create a separate table to connect these two. So we'll call them flight passengers. And this flight passengers, well, a passengers entity would connect to this flight. And we know that many flights would connect to this passengers entity. And, oh, I apologize. That should not there. All right. And then my flights would also connect to that flight passengers. And the way this would go, I apologize, everyone. Let me go ahead and add here passengers. And let me add here flights. All right, so then this way, when we query the database, we have a place where we're joining this information to allow this many-to-many relationship to speak to one another. Brandon, go ahead.
So we're effectively merging two previous data structures into a new data structure in order to get the information we want, but we're doing it on the backend side.
Right. We're just creating. You're right. It's just we're doing it with tables rather than data structures, which I think what you use as far as verbiage. But yes, that's correct.
Yes,
It's the same
okay.
concept.
Okay, thank you.
Of course. Any other questions regarding many-to-many relationships? Oh, and I see Eric in the questions channel. He shared a YouTube video regarding normalization. I strongly recommend you check that out. All right. Okay. It doesn't seem like there are any other questions. So we're into the practical application part. It's currently 7:55, so let's try to at least knock down one of these, if not all three, before we go into our break. So here we go. The practical application portion. So here's our prompt: design a database schema for a pet store. Right? So the store sells different types of pets and keeps track of customer transactions. Each pet has a breed, age, and price. Customers can make purchases, and the store wants to maintain the information on the customer details. All right, so just from that one, or just from this small paragraph, how many tables do we think we're going to need to be able to make this database here? Go for it, Momo.
3 tables.
Okay.
That's look like it's many relationship.
Yeah, let's check it out. Let's see. So we have a database for a pet store. The store sells different types of pets.
Yeah.
So we have a pets table. We could have a types table, right? Or depending on what kind of type it is, maybe we have birds, cats, etc., etc. That should be handled separately as well, right? So there you go. There's 2 already. Then there's customer transactions. So it looks like we have to keep track of the customer itself and then the transactions. And it gives us a little bit of information in regards to the customer. So I would say maybe 5 data tables. And it looks like 4 was the correct answer, right? So we have our pets with the correct information. Now we have our bar chart, age, and price. We have our customers. We can see this snowflake here. That's saying that this is a unique field. So every customer that we have should have a unique email. And it looks like the phone number is nullable. And that's why we have that question mark at the end there. All right. When it comes to a transaction, well, many transactions can belong to one customer. And a pet can be registered in many transactions. So we can see that there's a connection between the pet to the transaction, and the transaction itself is in charge of grabbing a specific transaction and connecting it to a customer. All right. Does anyone have any questions regarding this first scenario? Momo, I see you have your hand up. Is that an old hand or is that the okay, old hand. Got it. Okay, good. Typically we'll go through these ourselves together, but we are running out of time. So let's look at the second one. So prompt, create a database schema for a system that tracks information about cars and their owners. Each car has a make, model, and year. Owners have names and addresses, and the system should be able to handle multiple owners for a single car. Okay, what does this sound like? Let's hear it, Chris.
I want to say many to many relationship, since multiple people can have this used to have the same car, and yeah.
Okay, so you could have it where multiple people own one car and one car belongs to multiple people. That makes sense. Let's see here. So there's our car, here's our owners, and there's the many-to-many relationship, right? Where we have our separate table of car owners, which handles the many connection of many cars to the car owner table, and many owners to many cars. So there we go. Many-to-many relationship, total of 3 tables. Great. All right, and then the big whopper, right? We have a school management system. So design a database schema for a university management system that efficiently tracks information about students, classes, and grades. All right, so there's our first one. All right, so it looks like we have 3 tables there. We have students, classes, and grades. The system should be able to store details about individual students, including their names, date of birth, email, and enrollment. It should also handle information about different classes, such as names, instructors, start date, end date. Additionally, the system needs to record and manage grades for each student in each class. Okay, so there's a many-to-many relationship for grades, right? Because many classes can apply to many students, but each occurrence of that should have a grade as well. So there we can see grade, and here's our many-to-many relationship between students and classes, and our 2 separate tables of students and classes. All right, does anyone have any questions over the 3 separate scenarios that we just quickly covered? Okay, fantastic. Well, so far we covered relationships. We covered the different fields that we can utilize with PostgreSQL, and we covered a couple of good practices that we should try to implement whenever we're thinking about database schema design and how to design our database schema. At this point, does anyone have any questions over anything I covered during this lecture? Ah, Len, shout out to the walking treadmill under the desk. Nice. All right, let's go ahead and stop our recording here. All right, welcome back, everyone. I hope everybody had a good time creating their database schemas on Drawsql. Now let's go ahead and actually start writing some SQL code. But before we actually start writing some SQL code, I want to talk about the different tools that we have when we install PostgreSQL. So as of right now, everybody here in the program, if they type psql Postgres, they should be able to enter their Postgres database. But what is PostgreSQL, or what is the machine structure, right? What are we looking at here? Well, what's happening? Oh, that ain't it. Try that again. Is we have our local machine here. And within our local machine, we always have a service running for PostgreSQL. And this service is always running on port 5432 by default. Unless you changed anything as to where it's located, that's usually where Postgres will always be running. Some people try to change the port where it's running or where you can find PostgreSQL for security reasons. But as far as our own local machines, it's okay to keep it within 5432, right? So there we have PostgreSQL, a port 5432. It's installed within my local machine. Now, I also have a couple of other things installed in my machine, but they're not necessarily running as a background service. So what do I mean by that? Well, I have Python installed in my machine, but it's not running, right? Like it doesn't run until the moment I type Python and then name of script. Then it compiles my code. But immediately after compiling that code or executing the file that I wrote, once it's done executing that code, or there's no more follow-on steps, because if it's a dynamic language, Python shuts down, right? So it has an automatic on and off switch, right? We also have Node running within our program, and Node works exactly the same way. Right, it's able to compile JavaScript code, but it also has its own on and off switch. Once it runs and it's done completing or executing some sort of code, it shuts down. Now we have seen a couple of services being provided through Python or Node extensions, right? Whenever we ran our Vite server, well, V was consistently running a server on port, I think it's 5374. I may be wrong there. But somewhere along those lines, right? Where Vite would run a server. And you'll notice that that server was running consistently. It was occupying my PostgreSQL, or my terminal, I apologize, right? It was occupying my terminal the entire time. When I ran npm run dev, it was consistently occupying my terminal. And the only way that it would stop is if I ran Control-C, which ran it off. So it was not automatic and not on daemon. Now, daemon mode. What does daemon mean, right? Daemon actually stands for running as a background service, meaning it's not going to occupy my entire terminal whenever it's being executed. Well, V would occupy my entire terminal. I would have to manually turn it off and on. So it was not automatic, but it did provide a service occupying a port in port 5374. Right? Additionally, not only did we see this with Vite, we have also already seen this with a backend server when we ran Flask on port 8000. It was also not an automatic off and on, and it did not run on daemon mode. Whenever we executed that one specific file, we had to manually turn it off. Well, what about PostgreSQL? Well, PostgreSQL does not have an automatic on and off switch, and it does run on daemon mode, meaning that even though I don't see this running, whenever I ran my Vite server, it was on my terminal occupying that port. Whenever I ran my Flask server, it was on my terminal occupying port 8000. Well, PostgreSQL is running consistently inside of my local machine, but it's running on port 5432, right? It is a background service working through daemon mode. Does anyone have any questions about this so far? Okay, doesn't seem like there are any questions. So now let's talk about a tool or a script that comes in with PostgreSQL. When you installed PostgreSQL, the tool of psql was also installed alongside of it. Now, psql is not the same thing as PostgreSQL. All right, what psql is psql is a tool to interact with PostgreSQL databases. Now, there's a difference here, right? So psql is a tool to interact with PostgreSQL databases, meaning many. But I know there's only one PostgreSQL running on my local machine. So psql can actually talk to any sort of PostgreSQL database that's deployed on some sort of cloud. Maybe it's on a different machine. Maybe we have it inside of some sort of other service. For example, for anybody interested into looking into it, AWS provides an RDBMS service for PostgreSQL. You can start an actual PostgreSQL server on the Amazon cloud in AWS, and you can connect to it through your local machine utilizing psql. All right, so psql can talk to many PostgreSQL instances. It can interact, enter just the way we did earlier, or it can actually run commands if we want them to. Let's talk a little bit more about this PostgreSQL tool. All right, so PSQL has a couple of different things running under the hood. When I type in PSQL Postgres, for us, it's just sending me straight to my Postgres database. But what's actually happening under the hood, right? What are all of the assumed values that are being inputted here? So PSQL has a value for host. And for host, if you don't provide one, it will always default to local host. Then it has an argument for port, which again, if you don't provide one, it will default to 5432. Finally, it has a database argument. Which database is it that we're trying to enter? Well, in this case, I want to enter the Postgres database. All right, what about a user? Well, I can also specify the user being myself, Francisco Avila. All right, well, when I run this command, you'll see that it has the same exact behavior. It goes into my local host, my local machine, finds port 5432, ensures that there's a PostgreSQL service being ran on that port. It then talks to that PostgreSQL service and ensures that there is a Postgres database. And then it makes sure that there is a user with the named Francisco Avila. And if there is, it logs me in and puts me into the PostgreSQL database. All right, so that's what happens when you run PSQL space and then the database name. Does anyone have any questions about this so far? All right, it seems like it's pretty straightforward. Let's take a look at what we have here. Let's touch some GameStore.sql. All right, so we've seen something very similar to the command I just provided to us before. And we saw it when we were working in Flask. All right, so if I were to comment out this here up above, well, we're seeing it in PSQL, but we've seen a URI in Flask. And a URI is essentially the same thing as the PSQL terminal, right? When we talked about the URI, it said, hey, I want to utilize a PostgreSQL database. This PostgreSQL database will utilize PsychoPG. It is currently located at my local host in port 5432. And, ooh, I can't remember off the top of my head. Let me see if I could find it here really quick. Oh, look at that. I got it all messed up. So the first thing was my username, right? Where it would come across like this as Francisco Avila. If I had a password, it would go here. So let's say my password was 1234. That would say, hey, the database is located at localhost port 5432. And the name of my database is Postgres. right? So we've seen this before, and this is actually something that you can execute with psql. All right, I would just remove that psychopg portion since we know that's specific to Python. I could copy this, and I could say psql, paste that URI, and you'll see that it still locks me into Postgres. There's just two separate ways that I can read this information. All right, we're logging into a PostgreSQL database. The username is Francisco Avila. There's the password. My localhost is my localhost is where this database is located, and it is at port 5432. And I want the database Postgres. All right, so there's two separate ways that we can specify this psql command, but they both do the same thing. They're just routing through my actual machine to find my PostgreSQL database and log me in as the user. Does anyone have any questions about this so far? Okay, great. All right, go ahead, Mama.
Yeah, the psychopg, that's the one like the interpreter, right?
Right, that's the one that's working like as an interpreter between Python and SQL code.
And SQL code. Okay. So why did you delete it here?
Because in this case, I'm not utilizing Python, so I don't need psychopg as a dependency.
Oh, okay. Okay, thank you. Okay.
Of course. All right. So now let's take a look at our schema design here, what we have, right? We have our game CSV. I'm gonna go ahead and create this into a table, and I'm going to try to load all of this data into my database, right? Which as of right now, actually, what I should look at is the different databases that I have. So let's see, I have CPDB, ecom, and there's the game store. So I need to erase the game store. As you can see, I have quite a bit of databases here. So I'm gonna go ahead and drop database, and the database that I want to drop is named game store. All right. So there it is. It dropped the database. And now I'm going to go ahead and create database game store. All right. I'm going to connect to said database utilizing \c, which will connect me to a specific database that I want to talk to. In this case, it's going to be game store. And now I'm in game store. Logged in as Francisco Avila. Okay, great. Does anyone have any questions about how I created that database and connected to it? All right, well, just in case someone needs those commands, I just sent them here on our X-Ray Slack channel. So now that we've created our database, let's look at our schema design for a game. All right. So here we have a game which already tells us we have a big integer ID. Okay, great. That's working pretty well. What about my game title? What I want to use to hold a game title. Does anyone have any ideas? Go for it, Raven.
Varchar.
Yeah, let's do a varchar. I don't necessarily need 255. I doubt it'll get any crazier than 100 characters per game. All right. And we're not necessarily worried about constraints as of right now, so we'll leave it as is. So we have our game title with a varchar of 100. All right, what about quantity? All right, quantity of copies. What should that look like? What type do we want there? Chris?
Maybe small int since it's only 2 digits. Would
Yeah.
that be?
We could try that. Let's see. Just to be safe, I'm gonna go with integer because maybe
Okay.
small int sets some sort of limitation that I don't know about.
Okay. Gotcha.
Yeah. And let's see, finally we have price. Anybody want to help me out with price here? All right, let's hear it, Daniel.
Yeah, we want to make that to a decimal, right?
Okay. Decimal.
And then we can put the first parameter as, can we do as 4
Mm-hmm.
and then 2?
All right, 4 and 2. Fantastic. Okay. So there we have our game title, quantity, and price. And I can see here that this says game ID. So I'm actually going to change this to game ID. All right, Erica, go ahead.
Not super relevant, but I would make the price the decimal 5 too, because some games are definitely in the 3 digits.
Ooh, all right. Yeah. We definitely can. I don't see a reason not to. Hopefully, I mean, I wouldn't buy a game if it was above the $100, but yeah. All right, so there we go. We have our game and we have our table set up. But how do I turn this table into SQL code? There's a couple of ways to do it. I do want to tell everybody that there is a capability in this platform here. You can, oh, go ahead and extend this here. You can click on file and export said file. You could actually click on the export to PostgreSQL schema, and it will export a PostgreSQL file for you or a SQL file for you that you can run on PostgreSQL. It's not 100% accurate, so I don't recommend using it all the time. Something very simple, you definitely can. Just know that that tool is there for you, and if one day you need it. All right. So now we have our schema here, my schema design. It's set up. How do I turn that into SQL code? Well, the first thing I'm going to say is I want to drop the table if exists. And the table that I want to drop is game. Otherwise, I'm going to create table game. And I am doing this so that every single time I run this script, it's going to drop the game table and then recreate it just from scratch, right? Now, I don't have any data necessarily in there. The only data that I already have it in CSV files. So I don't necessarily have to worry about data conservation. So it's okay for me to continuously drop my table as of now. I'm experimenting, making sure that my database is going to work how I want it to. All right, so that's the reason for that first statement of drop table if exist. And this kind of looks like a function, right? Well, I want to create a table. I know that at the end of my statement, there should be a semicolon, and I'm going to create my table of game. Well, how can I do that? Same thing, we have my game ID. I'm also going to have a game title. I have my, and let me just make sure that's what it's called here. Yeah, game title. Then we have quantity and price. All right. Well, just like we did on the right-hand side, where we determined the individual types, we just add the types here as well. So here we know we're going to run into an integer primary key, right? Because that's what we want. We want to make sure that this is analyzed as a primary key. And I'm going to show us something in regards to serial primary key here shortly. All right, and then we have our game title, which we talked about. We said we wanted this to be a bar chart, and we said that it wouldn't get any more ridiculous than 100. And then we have our quantity, which is also an integer. And finally, our price, which is a decimal of 5 different places with 2 as our decimal. All right, and now we're handling money. All right, so there you go. I'm able to create a table with the game ID. Here's my game title and my quantity. Okay, great. Go ahead, Len.
This is definitely kind of a left field question. Just say pass if you need to. It's about the price thing there. And I'm just thinking if you were to sell in different markets, like in like the yen or something like that, where like the decimal places are like, or the numbers are much larger, like would you do that with a different table? Or would you take the price decimal there and increase the number? You know what I'm saying? Do you know what I'm trying to say?
Yeah, definitely. I think I would have a table named prices, and I would have a relationship between the price and the game. And then depending on the currency, that would be the price that gets pulled out of that relationship.
Okay, that makes sense. Thank you.
Of course. All right. So there we go. We have our drop table if exists. Everything seems to be working well. Well, let's actually make sure that it is working well by copying some data. All right, I want to grab all of the data from my CSV file and place it into my database. I'm going to run the \copy command here. I want to copy games, and actually this would be game because that's what I named it. So that's the name of the table. And I want to copy it from, and here's where I would specify the path. Now notice I'm utilizing single quotes. Please ensure that whenever you're working with quotation marks inside of PostgreSQL, it's always going to be single quotes. Right? So now I can take a look at the path here. I can also utilize my terminal. If I run ls, I see that I have data. And if I run ls data, I see that game.csv is in there. So I can specify from here, I want you to go into data and grab game.csv. And then finally, because this is a CSV file with headers, I can say this has CSV headers. And I don't necessarily need to specify the delimiter. It is good practice. We'll do it this way from now, and then we could experiment about the delimiter afterwards. All right, so there you go. I have my games, my copy command. But now how do I execute it? And I see we have a question. Let me execute this code, and then afterwards we'll open it up for questions. All right. So I'm actually going to run here in my terminal, excuse me. I'm going to run here in my terminal \i, and I'm going to run game store.sql. All right, and I see that I have an issue with CSV headers, and I believe that's because of my S. It's just CSV header. So let me run that again. So there we see that the table was created the first time I tried to run it, but because I had a syntax error and never copied the data, so now I was able to drop the table, create the table, and copy all 10 rows of data. So let's take a look here. If I run \d, we see I have a public game table. There's the owner, Francisco Avila. And if I select all from game, we can see that all 10 of my game entries have been placed into my database. All right, let's open up the floor for questions. I believe, Brandon, you had something you wanted to throw out there?
Oh, I was just gonna talk about the header and headers, and I thought it was gonna be a problem, but I gave you the alert anyway, so.
Thank you. All right, anyone else? Any questions as far as what we just did? Chris?
What was the command to, I guess, run it, to copy the game and start it?
Yeah, it's going to be \i and then the name of the script.
Gotcha. And then it leads to the game store equals number. Or is it part two anything? I was writing notes when you was doing it.
No, as soon as I ran \i game store.sql, it just executes the entire script here.
Gotcha. Thank you.
Of course. And then there's a couple of suggestions here from Brandon, if anybody would like to try them out. Seems like it could be useful. All right. So now we have this table. And if I run my \d here to see the relationships, I can see here's my list of relations of my tables to this one database. I can only see that there is a game table. But what if I wanted to create a new entry here? Right? Let's see. Let's say I copied all my stuff, and now I want to run an insert statement. Ooh, and now I'm gonna put myself to the test here. Let's see if I remember how to do my insert statements. So I'm gonna insert into game the values, and then the values that I want to insert is going to be a game. Oh, hello. Game title, quantity, and a price. I think this is width. And then this is values. And then the Valiant would then be Francisco's game. The quantity would be, I don't know, let's say 1. And the price would be a nice and cheap 1055 game. All right, there you go. All right, let's close that statement. Let's see what happens when I try to execute this. Which I'm pretty sure I'm going to have a syntax error. Syntax error near game. All right, let's see.
I think it's insert into.
Is it insert into game? Yeah, it is. Nice. Thank you. There you go. All right, so let's try that one more time. So there we see a syntax error. I wonder where this one's coming from.
I believe it's because you don't need quotes for the game title, quantity, and price.
Huh, maybe. Let's try that. Game title, quantity, and price. Let's see that. There you go. Yeah, that's it. Thank you. All right, so now we got our insert statement. We're trying to insert a new record, right, into PostgresQL. But when I try to do this, it tells me, hey, wait a minute, you're trying to do this without providing an ID, and a primary key is not something that's nullable. So if you want to insert something, you have to insert a primary key. Well, that's not necessarily the behavior that I want out of my database, right? I would want it to execute on its own, or to continue moving forward on its own. Let's see what happens if we run a serial primary key. We're not going to copy CSV data as of now. And we're actually going to make another insert statement, right? And instead of Francisco's game, let's call this Adam's game. All right, let's see what happens when I run this. Into game does not exist. Okay, so it looks like it got a problem here. Let's see what we can do. Got it. It was this integer portion. All right, so serial primary key. Let's run that. All right, there we go. So now I took off the integer part because since we're making it a serial primary key, it is assuming that it will be integers. And now let's take a look at what we have in relationships. If I run a \d, here we can see we have our game. And down below we have our game ID sequence. That wasn't there before. All right. So let's take a look at what's in there. Select all from game ID sequence. Well, if we take a look there, we have the last value, that has been currently inserted. So notice that I inserted 2 records. So the last value is 2. It has been called, so it's set to true. And then it has a log count. All right, well, that's great. If I continue to make new records, if I go into select all from game, you'll see that this is automatically being aggregated for me, right? I don't have to worry about it. Well, let's see what happens when I drop. If I were to remove a record from up above here, it would remove it, and it would still maintain Adam with 2 as the game ID, and it'll continue to aggregate properly. Right? We're never going to have a repeated record by turning it into a serial primary key. All right. Now, common practice, always use serial primary keys whenever you're trying to create a new table. Now, this does raise an issue. All right. Let's run this here. Oh. When I run this now, I go to create it, I drop the table, I then create the table of game with a serial primary key. If I run \d, if I run \d, we see that I still have my game ID sequence, and I copied all 10 of my files. Well, let's see here. Gonna run select all from game. We can see all 10 of my games were successfully loaded. But what happens when I run select all from game ID sequence? Well, we have an issue here. Does anyone see the issue? Well, if you look here, oh, look, I thought I saw a hand up. All right. Well, if you look here, my game ID is all the way up to 10. But if we look at the last value that was called for my serial primary key, it says that it's only 1 and that it hasn't been called. So I copied my CSV data, but by copying my CSV data, I essentially broke my code, right? Because now if I try to run an insert statement, the new record that is being inserted would only have the ID of 1. So let's run this script here with \i. And there we can see the issue, right? It's telling me, hey, we have an error. You're trying to set duplicate keys for game primary key. And the game ID of 1 already exists. Well, according to my sequence, it doesn't. Right, so how do I fix that? Well, there's a very specific line of code that you utilize to fix this. We're not going to talk too much about its in-depth functionality as of right now. We will talk about it later on. But essentially what I want to do is I want to change that last value to be the max value that was copied from my CSV data. All right. The way I do this is I select a function called setValue. The value that I want to set to is called game ID sequence. Let's make sure that's correct. \d. So there you go. Game ID sequence. All right. And what I want to set this to is I want to select the max field for game ID from, this is just a simple query here, game. Oh, there you go. So this is going to grab the max from game ID from game, which we know it's going to be 10, and is going to set the value of game ID sequence to 10. Well, let's see what happens now. All right, and let's actually run a select all from game ID sequence. And let's actually run this twice. All right, so we should see it at 0 after the copy statement. Then we'll see it set the value. And we should see it at 10. Well, let's execute our command here. All right, so let's see what we have. So first thing it does is it drops the table because it does exist. It's running from top to bottom. It then creates the table of game. Great. It copies the data that I have in my CSV file. So it copies it correctly. After that, it runs my select statement. I want to see what my ID sequence look like. It's currently at 1, but I know that's wrong and that it should be at 10. Then we see the set value function sets it to 10. Finally, I see select all from game ID. We can see the last value is 10. And look at it, it's called Boolean variable is now true. I then insert a new row and it's able to insert successfully. So if I were to select all from game, I can see Francisco's game at the very bottom with the correct ID of 11. All right, so it took a little bit of moving around and making sure everything was in the correct place. But now I have my data with a serial primary key being copied from a CSV file and working correctly. All right. Does anyone have any questions at this point? Go ahead, Roshan.
Can you explain more on how it turned the boolean from false to true and what does it actually do?
Yeah. So the Boolean of false to true essentially just says, hey, I've been called before, so grab this value and aggregate to it. Right. So as we saw in that last command, when it's set to true, it was at 10, right? Well, when I made a new record, it grabs 10 and says, all right, well, has this value been called before? Sees true, and it says, okay, then I need to add one more. And it sets it to 11, and that's how Francisco gets the ID of 11. Whereas if it was false, it wouldn't add that +1 before trying to set it to a record.
Okay. Yeah, that makes sense. Thank you.
Of course. All right, any other questions? All right. Let's talk a little bit about altering statements. Now, note that altering statements can be used at any point to alter anything within your tables, right? You could alter the actual value inside of it. You could alter the data type inside of it. It's just something that you can utilize at some point to actually alter the value. If this schema design was hundreds of lines long and I identified a problem, rather than going all the way back, trying to find exactly where this table is being created, I would then utilize an alter statement. So let's say, and this is not something we would actually do, but let's say for quantity, we discovered that quantity we needed to be a big integer, right? We have grown, we actually handle up to thousands of copies of each individual game now, so I need it to be a big integer. Well, how could I do that? I would simply just say, hey, I want to alter a table. The table I want to alter is named game. And what I want to do is I want to alter a column. Right? That column name is named quantity. And what I want to do is I want to set the data type to big int. And let me make sure that that's correct syntax by seeing it highlighted. All right, it is. All right. So that's all I want to do. I want to change that data type to big integer. I don't really need anything in constraints per se. But let's go ahead and add that here. Constraint. So that it applies all the constraints for that specific type. Well, now if I execute my code, I see that I have an issue here. So syntax error on or near. So alter column quantity. Let's set data type. Let's see, I'm gonna grab our example here from straight from the curriculum. We might have an issue in regards to this code here. So this here would be game. And what I'm trying to change is quantity. And this would be a big int. There you go. Oh, and that doesn't take that. There you go. All right, and now we can see that the alter table statement was taken into effect. And if I wanted to check it, I could make a new insertion where my quantity, rather than only being handled at the integer level, would be handled at the big integer level. All right. That is all we have for today. At this point, does anyone have any questions over anything that we covered today? Go ahead, Erica.
Yeah, about that last bit. So we would do alter table to alter one of the tables created in order not to lose data that was already introduced to it. Why not just modify the CSV and reload the data, or just have it in that?
Yeah, that's a great question. So let's say this file was hundreds of lines long, right? And the CSV data is clean, like the CSV data is fine the way we want it to work. Rather than trying to scroll all the way up to try to find exactly where this create statement is, and then just changing that line, I could save myself time by just running an alter table statement and changing it later on in the path as it's being executed right before it needs to change. Does that answer your question, Erica?
Yeah, somewhat. Would it not be possible to just, for example, instead of inserting directly to the database, to just modify the CSV? Why would we still have the CSV? That's just like the original way that the database was created, and then we just started modifying it within the database itself, and that's why we're doing this.
Got it. So what you're asking is, why do we even have the CSV? Is that correct?
Yes.
Okay. So most small businesses nowadays, unfortunately, they usually default to something like Excel or Microsoft Sheets or something like that, or Google Sheets, to try to keep track of everything that they're doing in their business. And the easiest way to export that is through a CSV file. So typically as developers, what we're handed whenever we start working for a new company, or we pick up a client and they already have a product or some existing data, we're handed a CSV file with data for us to work off of. Does that answer your question, Erica?
Yeah, makes sense.
All right. Any other questions? Okay, awesome. It doesn't seem like there are any questions. Today, we spoke about good and bad practices of database schema design. We spoke about how to utilize Drawsql to create our different schemas, and a little bit about relationships. We also drew out what psql and postgresql actually are and their differences in between and their functionality. And finally, we covered how to turn our schema design from Drawsql into actual PostgreSQL SQL data that we can be executing within our PostgreSQL terminals. At this point, does anyone have any questions over anything we covered during this lecture? All right, if there aren't any questions, I'm gonna go ahead and stop the recording.